In the previous video, we solved some problems relating to load, effort, and mechanical advantage of a lever. Now we are going to look at the three different types or classes of levers. Each class has a different advantage and sacrifice. Each of these classes of levers depends on the location of the load, fulcrum, and effort force. In a first class lever, we have the fulcrum between the effort force and the load force. An example of a first class lever would be a pliers or a pry bar. Next, we have a second class lever. In a second class lever, the load is placed in between the effort force and the fulcrum. An example of a second class lever might be a wheelbarrow or a nutcracker. Last, we have the third class lever. In a third class lever, the effort force is in between the fulcrum and the load. An example of a third class lever might be your forearm. We are going to take a closer look at each of these different types of levers and what are some of their distinguishing characteristics. In a first class lever, the fulcrum is between the load and the effort force. In a first class lever, the mechanical advantage is always larger than 1. A first class lever is used when we need the load force to be larger than the effort force, even though the load force cannot be moved as far. Some examples of a first class lever are a seesaw, pry bar, or pliers. In each of these examples, we apply an effort force on the opposite side of where the load force is located. In Class 2 levers, the load is located in between the fulcrum and the effort force. In a wheelbarrow, the fulcrum is the wheel, the stuff in the wheelbarrow is the load, and the effort force is the person lifting the handles. In a nutcracker, the effort is applied to the handles, the load is the nut, and the fulcrum is the hinge at the end of the nutcracker. In a third class lever, the effort force is located in between the load and the fulcrum. This is where the advantage and sacrifice come into play. The effort force you apply is greater than the load, so the sacrifice is the force. However, the advantage is the distance the load moves, so the load moves farther than the effort force moves. As an example, in a baseball bat, the handle is the fulcrum. You supply the effort force near the middle, or where you hold the bat, and the other end of the bat, or the part that hits the ball, is the load. The resistance or load force moves farther than the effort force. Your forearm is another example of a third class lever. Your elbow is the fulcrum, and you hold a load in your hand. The effort force is applied by your bicep, which hardly moves, but you can make the load in your hand move a great distance. In the next video, we will look at some examples using the three different classes of levers.